Hello everyone, this is Dr. Nak, and we are about to go over the practice exam number 2. If you're using OpenStax textbook, it will be on Chapter 8 material, and if you are using Blitzer textbook, it will be on Chapter 10 material. But anyways, let's just get started. Alright, number 1. Simplify each expression or state that the expression is not a real number. So first thing first, what you need to know is this. So please note that nth root of a to the n, this is going to give you an absolute value of a if n is an even number, such as 2, 4, 6, and so forth. And then it's just going to be a little a if n is odd numbers. Alright, so let's just look at part A. Notice that you're giving a square root, which is the eventh root. So what's going to happen is this. So this is going to equal to, should we put the absolute value or not? Yes, we do, because you have the square root of x plus 4 whole quantity squared. So it is going to be absolute value of x plus 4. And that's the answer. I don't know why I just wrote that in red. I apologize. Alright, let's go to the next one. Part B. Square root of 25 minus 64. Okay, first of all, if I compute that, do you see that I'm going to get a negative number? Negative 39. Look at the question. Question asks you, simplify the expression or state that the expression is not a real number. Now, can we have negative number inside of the square root over the real number system? Absolutely not. Imaginary number, fine, but we're talking about the real numbers here. So your answer is going to be not a real number. All right. Let's go to the next one. Write the expression with a positive rational exponent. Simplify. If rational exponents appear after simplifying, write the answer in radical notation. Assume that all variables represent positive numbers, which means that, woohoo, you don't have to worry about that darn absolute values anymore. Only absolute value problem that you're going to get is number 1, just so you know. Alright, anyways, let's get started on this. So part A, 16 over 126 to the negative 1/4 power. Alright, so there are multiple ways that you can do, but what I will do is this. Let's rewrite this guy as 16 to the negative 1/4 over 256 to the negative 1/4. Remember, if you have a over b to the n, this is a to the n over b to the n. That's exactly the property that I just used. Now, notice that 16 is on the numerator with the negative exponent. We don't want the negative exponent. So what's going to happen is this. Let's just talk about this a little bit. If I have a to the negative n, let's just say, how do I make that into a positive? You flip the a and then attach the positive exponent on the a. Oops. Alright, so with that said, if I have a 16 to the negative 1/4, do you see that 16 is going to go on the bottom with the positive exponent of 1/4? So what we're going to get here is 16 to the positive 1/4. Now, let's take a look at, let's take a look at 1 over a to the negative n. Now, how do I make that into a positive exponent? All you have to do is bring the a on the top and then attach the positive exponent. Alright, so with that said, what's going to happen is 256 is going to go on the top with the positive exponent of 1/4. You're not done yet. Alright, so let's rewrite. So this is same thing as what? 4th root of 256 over 4th root of 16. Now, we're going to have to break this down a little bit. So let's do it as a side work. Just going to go on this side this time. Let's break down 256. All right, so 256 is even, so 2 is going to go in all the time. 2 times 128. 120 is what? 2 times 64. 64, 2 times 32. However you want to break it is okay, as long as you break it down to all prime numbers. 32 is what? 2 times 16. I'm running out of room. All right, 16 is 4 and a 4, 2 and a 2, whoop, 2 and a 2. So how many 2's we got going on? We got 1, 2, 3, 4, 5, 6, 7, 8. So 256 is 2 to the 8th. Now let's go with the 16. All right, 16 is 4 times 4, which is 2, 2, 2, 2. So 16 is 2 to the 4th power. All right, now let's try to rewrite this by using the exponent. So 4th root of 256 is going to become what? 4th root of 2 to the 8 over 4th root of 16 is going to become 4th root of 2 to the 4th. All right, now we got to go simplify this a little bit more. Notice that the root 4 will divide 8, this exponent 8, and this exponent 4 nicely. So if it's nice, what I'm going to do is I'm going to circle the one that's going to be divisible by the root 4. So what answer is going to be 2 to the 8 over 4 over 2 to the 4 over 4. That's how it's going to work. So this is what? 2 to the second power over 2 to the first, which is just 2, which is 4 over 2. So the answer is 2. All right, so I'm just going to box this. Why is that orange? Sorry. 2 is going to be the answer. All right, moving right along. All right, part B. Okay, do not be afraid. Take one step at a time. Please note this property right here. Note that if you have AB to the n, this is A to the n times B to the n. Okay, and furthermore, if you have B to the m over B to the n, this is going to be B to the m minus n. So there are two properties that you should know. Okay, so let's get started on this. So first, what I'm going to do is distribute the exponent 4 to each term in the numerator. And let's just leave the bottom alone for now. All right, now let's start simplifying. Negative 3 to the 4th is negative 3 times negative 3, 4 times, right? So that would be what? Negative 81. And y to the another property that you should know would be this. If you have b to the m, oops, excuse my handwriting, b to the n to the mth power, what do? You multiply the exponent. This is going to be b to the n times m. Okay, so I'm going to use that property here. So this is going to be y to the 4 over 3, because 1/3 times 4 gives 4 over 3. Now whole thing over y to the 2 over 7. All right, now let's stare at this for a little bit. Notice that I could still simplify this quantity. Okay, so what we're going to do is we're going to be using this property over here. Okay, so let's go one more step. So this is what? Negative 81. So this is going to be what? Y to the 4/3 minus 2/7. All right, so let's just compute this a little bit. So let's see, we need the LCD. 4/3 minus 2 over 7. LCD will be what? 21. So that means what? I have to multiply the first fraction on the top and the bottom by 7. 7, 7. Second fraction by 3 and a 3. So what we're going to get is what? 28 and then 6, which is going to give us 22 over 21. So this is going to become negative 81 y to the 22 over 21. You got to go one more step. You're going to convert that into a radical. Now please note that a lot of students get confused. Actually, I used to be confused with, sorry, that was my dog, which is going to become the root, which is going to become the power. Always remember, root grows on the bottom. So the bottom is going to be the root. So this is going to be negative 81. Please note that this exponent is only attached on the y, not on the negative 81. So here what you're going to get is 21th root of y to the 22nd power. And that is going to be the answer. Here we go. All right. Let's go to number 3. Use rational exponents to simplify the expression. If rational exponents appear after simplifying, write the answer in radical notation. Assume that all variables represent positive numbers, which means that don't worry about the absolute value. All right, let's get started. So let's work this step by step. You have 9th root of 3y. In terms of an exponent, that's what? 3y to the 1 over 9. But then you have the outer power 4. So let me just write it as power of 4. Okay, so now what? Again, what do I do with 1 over 9 and a 4? You multiply them. So here you're going to have 3y in the parentheses to the 4 over 9. Which is going to equal to, all right, which one is the root? Bottom is the root. And here you're going to have 3y whole quantity to the 4th power, which gives us what? 9th root of 3y times 3y times 3y times 3y should give us what? 81 y to the 4th. So that is the answer. Okay, next one. I know this looks really nasty. 5th root of square root of 7x. Okay, so let's work it step by step. 5th root will be something to the 1/5 power. Square root of 7x is what? 7x to the 1/2 power. All right, now again, we multiply these exponents. Make sure to have a parentheses around the 7x. So if I multiply 1/2 times 1/5, that's going to give us 1 over 10. All right, now, which is going to become the root again? I think the bottom. So this is going to be 10th root of 7x. And that's going to be the answer. All right, next one. I know this looks so nasty, but you can do it. All right, so first of all, let's stare at this for a little bit. You do not skip to the next problem, by the way. All right, notice that can we not simplify the y's first and maybe simplify this problem a little bit? All right, so let's take a look. You have y to the negative 9 over 5 over y to the negative 2/5. How do I divide these? You got to go y to the negative 1 over 5 minus top exponent minus the bottom exponent. Be careful. You're going to have a minus minus. So this is going to be y to the negative 9 negative 9 over 5 plus 2 over 5, which is going to give us y to the negative 7 over 5. All right, so let's just rewrite that a little bit. So this is going to equal to x to the 2/3, and then y to the negative 7 over 5 to the negative 3rd power. All right, it looks a little bit more nicer now. Now what we're going to do now is we're going to distribute this exponent to each term, which means this is going to be x to the 2/3 to the negative 3rd power times y to the negative 7 over 5 to the negative third power. Okay, what do I do with 2/3 and negative 3 again? You multiply them. So here you're gonna get x to the 2/3 times minus 3. Negative 3 is gonna give us, remember, 3 and a 3 is gonna cancel, so you're just left with x to the negative 2. And here you're gonna have y to the, when I multiply negative 7/5 and negative 3rd, you're gonna get what? Positive 21 over 5. My dog is getting excited about this. All right, now one more thing. You don't want to leave. You don't want the negative exponent. So let's rewrite x to the negative 2 into a positive exponent by flipping it, then attaching the positive exponent. Remember, y is still going to be on the top. Only thing that's going to get moved is the x, because x is the only one with the negative exponent. Okay, so let's rewrite this in terms of a root. Now bottom is the root, so you're going to have a 5th root of y to the 21st power, whole thing over x squared. And that's going to be the answer. Okay, next one. Use the rational exponents to simplify the expression. If rational exponents appear after simplifying, write the answer in radical notation. All right, let's do this. Okay, so since they're both fourth root, you can combine the two radicals into one. So first step, if I were you, I'll just go like this. And 8 times 10 is 80. X to the 9 times x to the 7th is, you add the exponents in this case. Oh, maybe in case you forgot, if you have a to the m times b to the, no, hold on, sorry. If you have x to the 9, let's just do this problem, x to the 7, what you need to do is you need to add x to the 9 plus 7. So in this case, you're gonna get what? X to the, and then yeah, so here what we're gonna get is 4th root 80 x to the 16th, and then here you're gonna get y to the 1st times y to the 20th, so it's y to the 21st. All right, now let's break this down. Okay, as a side work, I'm going to break down 80. Maybe 8 times 10, 2 times 4, that's going to go to 2, 2. 10 is 2 and a 5. So how many 2's we got? 1, 2, 3, 4. So it's going to be what? 2 to the 4th times 5. All right, so let's just break it up. So this is going to equal to, let's see, 4th root of 2 to the 4th times 5. Now for the variable part, let's look at x to the 16. Now the break-off point will be the biggest number before or equal to 16 that's going to be divisible by 4, the root 4. That will be what? X to the 16. Because 4 is going to go into 16. Now let's look at y. Y to the 21st. 4 is not going to go in. Now what is the biggest number that's going to go into 4 that is going to be less than or equal to 21? What's the biggest one? I think that will be what? 20? And then what's remaining? Y to the 1st. So I'm just going to leave it like that. Okay, next step, what I'm going to do is I'm going to circle the perfect ones. The one perfect means the guys that could go outside of the radicals, which means all the exponents that's going to be divisible by 4. I'm going to circle those. Now let's take a look. Now you have 4th root of 2 to the 4th, so that's going to be what? 2. X to the 16, 4th root of x to the 16, what do? You got to go x to the 16 divided by 4, it's going to be 4. And then y to the 20th, 4th root of y to the 20th is what? Y to the 20 over 4, which is 5. And the rest of the guys, 5 and a y, poor people. they cannot get out of the radical, so they're stuck in there. So that will be the answer. All right, now let's look at the next one, add or subtract. Okay, so first thing first, let's break down the square root of 90x to the 5th. So let's just break down 90. 9 times 10, 3, 3, 2 and a 5. So this is what? 3 squared times 2 times 5. All right, let me just try to rewrite it. So this equals 4 times the square root of 3 squared times 2 times 5. Now let's deal with x to the 5th. Now you're given square root. So what is the biggest number before 5 that's divisible by 2? That would be x to the 4th. Breakoff point is x to the 4th. What's remaining? X to the 1st. That will make it x to the 5th. And then over here, 10 is 2 times 5, so there is no perfect square, so I'm just going to leave it the way it is. All right, next. I'm going to circle the perfect ones. All right, now let's take a look. So you have negative 4 times, now square root of 3 squared is going to be 3. Remember, everything's being multiplied here. Square root of x to the 4th is x to the 4 divided by 2, which will be x squared. And the rest of it, 2 and a 5 and x, they are stuck inside of the radical. So 2 times 5 is 10, and then you have dx. Okay, let's simplify more. Negative 4 times 3 is negative 12. X squared, square root of 10x, minus the square root of 10x. All right, let's stare at this for a little bit. Do you see that we have the common terms here? Square root of x to the 10, and then another square root of x to the 10. Okay, so we could combine this together by factoring out the square root of 10x. So what we're going to do is this. Let's factor out the square root of 10x. Now what goes in the parentheses? Well, first one is going to be what? Negative 12x squared. And then here comes the minus. It's this minus right here. Now, what is sitting in front of this square root of 10? Do you see there is an invisible 1 sitting there? Okay, so you're going to have to put that in. So the answer is going to be square root of 10x times negative 12x squared minus 1 in the parentheses. If you drop the parentheses, your answer is not correct. So here it is. All right. Now let's look at the next one. All right, so let's simplify this. You got a 5 times the cube root. Now, x to the 7th, where's the breakoff point? The biggest number before 7, that's going to be divisible by 3. That will be x to the 6th. And then what makes it x to the 7? X to the 1st. And then y. And then here you're going to have minus 7x. Cube root, well, x and a y. There's no way that's going to be a perfect cube, so I'm just going to leave it the way it is. All right, so the only perfect one will be x to the 6th. So this is going to equal to 5 times cube root of x to the 6th is x to the 2nd power. And then you're going to have a cube root of xy. And then minus 7x. And then cube root of xy. All right, now notice that again you have something in two terms have something in common. Cube root of xy, cube root of xy. So we can factor that out. So cube root of xy. And then what goes in the parentheses is what? 5x squared, and then minus 7x. And That's gonna be the answer. You don't need to go any further. You don't have to factor the x out from what's in the parentheses. Just leave it the way it is. Okay. Oop. Okay, so the next problem, number 6, simplify that. Ugh, nasty looking. All right, we got this. So first, 256 over 81. I don't think 81's going to go in to 256 nicely. So what I'm going to do is I'm going to break it off. Oops. And cube root of 81, y to the 9th. Okay, now we got some work to do. All right, we're going to break down 256 as a side work. All right, so 250, I know we've done 256 before, but let's just go over it again. It's going to be what? 2 times 128. What did I do? 2 times 64. 8 and 8. 4, 2. 4, 2. 2, 2. 2, 2. I just did that kind of fast because I believe that we broke down 256 earlier in the problem. So 256 is 1, 2, 3, 4, 5, 6, 7, 8. 2 to the 8th power. All right, now 81. Let's just get this one over with. 9 times 9, 3, 3, 3, 3. So 81 is 3 to the 4th power. Okay, so let's just rewrite it. So this is going to equaling to cube root of 2 to the 8th, x to the 10, whole thing over cube root of 81, not 81, sorry, we broke down the 81. So it's going to be what? 3 to the 4th times y to the 9th. Okay, now what we're going to do is we're going to break this off even further. Now let's look at the numerator. 2 to the 8th, where's the break-off point? What is the biggest number before 8? That's going to be divisible by 3. That will be 6, I believe. So break it off at a 2 to the 6th. And then how much more do we need to make it into 8? 2. All right, and then let's deal with the x to the 10th. Where's the break-off point? So it would be x to the 9 times the x. And let's do the same thing for the denominator. So we're going to have a cube root. 3 to the 4th can be broken down into 3 to the 3rd times 3. And then y to the 9, I will just leave it the way it is because 9 is divisible by 3. All right, let's circle time. Yeah, that one's good. This one's good. This guy can go outside. This guy can go outside. All right, so let's see. So this is gonna, I'll just go over here. This is gonna equal to, all right, cube root of 2 to the 6th is what? 2 to the 2nd. Cube root of x to the 9 is what? X to the 3rd. And what remains is what? 2 to the 2nd, which is 4, and then x. Whole thing over. All right, now cube root of 3 to the 3rd is 3. Cube root of y to the 9 is what? Y to the 3rd. And then we're gonna have cube root of 3 left over. All right, so now let's just simplify this a little bit more. So this is gonna equal to what? 2 squared is 4, x to the 3rd, cube root of 4x over 3y to the 3rd times cube root of 3. I believe that is the answer. If I made a mistake somewhere, please let me know. All right. Now let's go with this one. Oh, you know what? If you like, sorry, I'm going back to the, whoops, where'd it go? This problem right here. If you want to, I'll accept this for the answer, of course, but if you want to combine the cube roots together, you can rewrite this as 4x to the 3rd over 3y to the 3rd, and then you can just put everything into one radical if you like. 4x over cube root of 4x over 3. They're both equivalent answers. So whichever you're comfortable with, just go with it. Now let's go to number 7. Simplify. Okay, so I'm staring at this a little bit. Do you notice that 5 is going to go into 125? And then maybe I could combine all the x's together and the y's together under the radical. So I'm going to approach this in a little bit of a different way. Alright, so what's going on with my pen? What? Sorry guys, my pen's not working. Okay, there you go. Alright, so let's take a look. We got 125 over 5, x to the 9th, x to the negative 6 on the bottom, and then y squared, and then y. Oops. Alright, so now if I simplify this, 125, first you might want to simplify 125 over 5, which will be what? 25, and then x to the 9 minus 6, top exponent minus the bottom exponent, and then y to the 2, and then minus 1, because there is an invisible 1 sitting there. Alright, so alright, here we go. So then now what do we got? We got square root of 25, and then what? X to the 16, no, x to the 15, and then what? 2, not 2, my goodness, I'm sorry guys, I'm so tired right now. And then what? Y to the first power, so I'm just gonna leave it like that. Okay, so now what? 25, square root of 25 is 5. Okay, or if I do it formally, it's gonna get what? 5 squared. Now let's break off the x to the 15. How about x to the 14 times x, and then y? So then here you're gonna so let me circle, let me just keep the same routine going. So this is gonna equal to what? 5 x to the 7th, because square root is 2, so 14 divided by 2 is 7, and then square root of xy. And here's the answer. Okay, moving right along. Alright, rationalize the denominator. Okay, so let's first take a look at it. Rationalize the denominator means you don't want to see a square root on the denominator, so you need to get rid of it. So let's think about this. If I have a square root of 5y, what kind of exponent do I need on 5 and also on the y? Since you're given the square root, do you see that if I have 5 to squared, y squared, do you see that this is going to become just a 5y, which is outside of the radical sign? That's exactly what we want, is 5y on the denominator when you rationalize the denominator for this problem. So let's take a look. Right now you're given just a 5y. What can I square root of 5y, I should say. What can I multiply to that to get square root of 5 squared y squared? Well, isn't it another just square root of 5y? If I'm going to do something on the top, I better do the same thing. I mean, on the bottom, I better do the same thing on the top. Because look, this means that, again, first I could break up the square root like this. If you want to do it that way, that's fine. And then what did I multiplied here by square root of 5y? Okay, look at the bottom now. If I multiply this, do you see that I'm going to have 5 squared y squared? So the bottom is going to be just a 5y. No more radical. So the magic quantity that you have to multiply is square root of 5y on top and the bottom. Okay. Alright, now, oops, don't forget the numerator, right? Okay, so now on the numerator, we got square root of 3 times square root of 5y, so you're going to have square root of 15y. So I'm just going to drag it like this. 15 does not contain any perfect squared, so this is going to be the answer right here. Okay, now let's look at the part B. We're still going to rationalize the denominator, so let's take a look at this. Oops. Okay, so you're given fifth root, and furthermore, let me see. Do you see that 4 can be written as 2 squared, and then we have x squared y to the fourth. Okay, so that's what the denominator looks like right now. Now, in order for this quantity to go outside of the fifth root, you need power of 5 on each single term. Okay, so fifth root, let me just write down the basis, 2xy. Let's look at the exponent on 2. It needs to become 5. So what is that exponent that's going to become 5? If I multiply with this guy right here on the left, that will be 3, isn't it? Because look, 2 squared times 2 to the third, you add the exponents, you're going to have 2 to the fifth. Now let's look at x. Right now you're given x squared, you have an x to the first, but you want to make that into a fifth power. So again, that number is 3. Now let's look at the y. You have y to the fourth, and then y. If I multiply that, do you see that I'm going to get y to the fifth? So just gonna leave it like that. And this, because look, if I multiply this out, let's see what we're gonna get. You're gonna get what? Fifth root of 2 to the fifth, x to the fifth, and then y to the fifth. Do you see that? So then what? This is gonna become just what? 2xy. So that's exactly what we want on the denominator. So what you need to do is this. This is the magical quantity that you're gonna have to multiply the top and the bottom of the given expression. I hope this makes sense to you. But anyways, so let me just rewrite everything out. So I'm going to first rewrite this guy as 2x squared y over fifth root of, I'm going to break down the base 4 into 2 squared because I don't want to deal with bigger number, x squared y to the fourth. Alright, now let's take a look at that magical number that I boxed it in orange. So here I'm going to multiply the top by the fifth root of 2 to the third, x to the third, y, because I'm going to multiply the same thing on the bottom. 2 to the third, x to the third, and then the y. Alright, now if I combine the denominator, do you see that I'm going to get fifth root of 2 to the fifth, x to the fifth, and then y to the fifth. And on the top, let's just leave it alone. 2x squared y, and then fifth root of 2 to the third, x to the third, and a y. Okay, now let's take a look at the denominator. Now denominator, remember these guys can all go outside now, outside of the radical. That's exactly what we did over here. Okay, so this is going to equal to, let's see, 2xy, and the top you're going to have 2x squared y, and then the fifth root of 2 to the third, that's what, 8, x to the third, and then the y. Okay, so now let's stare at this. So do you see that you can cancel out the 2's? Whoops. You can cancel out the 2's. And then what? You have x squared over x, so that's just going to become x. Or you can think of it as x squared is x times x, and you have another x on the bottom. So you could just cancel one of the x's. Okay, and then you can certainly cancel out the y's, I guess. And then what do we got left? So we got, so let me see. Note that x squared over x, this is just going to be x. So you got 2x, and then what? Fifth root of 8 x to the third y. And I believe that is going to be the answer. All right, so I hope this made sense to you. Again, if you have any questions at all you have to do is just email me right away. Okay, now let's take a look at the next problem. Oh wait, hold on, why do I have a 2 there? 2 canceled, correct? There you go. Lack of sleep will do that to you, so make sure to sleep before the test, you guys. All right, next problem. You're still rationalizing the denominator, so in this case what you need to do is the trick is to multiply the top and the bottom by the conjugate of the denominator. So in this case you're gonna have to multiply the top and the bottom by square root of 6 plus square root of 5. That will be the conjugate of square root of 6 minus square root of 5. And whatever you do on the top, you're gonna do the same, on the bottom, you're gonna do the same thing on the top. All right, now please note that you're gonna have to pretend that there's the parentheses here because you're about to FOIL this. Okay, now let's take a look. Let's go with the numerator first. So I'm going to first FOIL like this and then multiply with that. Next one I'm gonna go this way and then that way. Okay, so with that said, you're gonna have what? 2 times square root of 6 times the square root of 6, that's square root of 6 squared. Or you could put the 2 on the outside or the inside, it doesn't really matter. I'll just put it in inside. Alright, and then what? 2 square root of 6 times square root of 5. So here you're going to have plus 2 square root of 6 square root of 5. I'm doing this step by step. And then the inner term is going to be plus square root of 5 square root of 6. And the last term is going to be what? Plus square root of 5 squared. Now, denominator, we're going to do the same thing. We're going to FOIL this. So you got what? Square root of 6 times square root of 6, that's square root of 6 squared. And then square root of 6 times positive square root of 5. So it's going to be positive square root of 6 square root of 5. Inner term is going to be negative square root of 5 times square root of 6, and the last term is going to be negative times positive will give you a negative square root of 5 squared. All right, now these two are going to cancel each other out, and let's just keep simplifying this a little bit. So here what you're going to get is, let's work on the numerator. 2 times square root of 6 squared is just going to be 6, and then plus 2 times the square root of 30 plus another, hold on, did I make a mistake? Hold on. 2 times this, and then what did I do? Hold on. Square root of 5. Oh, no, this is good. Sorry. And then what? This guy is what? Square root of 30. And then here you're going to have plus square root of 5 squared, which should be just 5. And whole thing over square root of 6 squared is 6. Cancel, cancel. And then minus square root of 5 squared should give you just a 5. Now let's keep simplifying this a little bit more. So this is going to equal to what? 2 times 6, 12. Now do you see that I can combine these two? These are like terms, right? You have positive 2 square root of 30 plus 1. There's an invisible 1 sitting there, remember? 1 times square root of 30. So how many? You're going to have 3 plus 3 square root of 30. And then plus 5. Whole thing over 1. Now I think you can still simplify one more step. I could combine 12 and a 5. So here what you're gonna get is what? 17 plus 3 square root of 30. Okay, over 1, so I'm just not going to write over 1. Now, is 30, does it contain perfect square? Nope, does not contain any perfect squared. So, this is going to be your answer. Alright. Next one. Solve. And check your proposed solutions. So let's get to it. Okay, step number 1, when you solve radical equations, what you want to do is you want to isolate a radical on one side of the equation first. So what I'm going to do is I'm going to move the minus 4 by adding 4 on both sides. So let me just show you all the work that I'm about to do. So I'm going to go plus 4, plus 4. Then here what we're going to get is cube root of 2x minus 6 equals 4. Alright, next step, I need to get rid of that cube root. What kills the cube root is to the third power. So I'm going to raise left hand side by the third power. That means I better raise the right hand side by third power. Okay, so now what you're going to get on the left hand side is what? Oh, let me change the color. 2x minus 6 equals 4 to the third. So I believe that is 64. Okay, now what you're going to do is solve for x. So plus 6 plus 6. And here what you're going to get is 2x equals 70. Dividing by 2. And you're going to get x equals 35. Now that's the proposed solution, but it says check. Okay, so let's check. Alright, so what you need to check is when x is 35, so which is what? Cube root of 2 times 35 minus 6 and then minus 4. Is it really going to equal to 0? That's what you need to ask. So let's just compute the left hand side of it. Alright, now, so here what you're going to get is cube root of 2 times 35 is 70 minus 6 minus 4. Okay, so that's equal to that. Now this is going to be what? Cube root 70 minus 6 is what? 64 minus 4. Alright, now cube root of 64, so if you can't figure it out, because I'm really tired right now, I can't figure it out, so I'm just gonna go like this. Okay, so if I divide this guy by 2, you're gonna have 2 times what? 32. And then if I divide this guy again by 2, you're gonna have 16. I could go from here. Yay, 4, 4, 2, 2, and then 2, 2. So 64 is what? 2 to the 1, 2, 3, 4, 5, 6. 2 to the 6. Okay, so here what you're gonna get is cube root of 2 to the 6. You don't have to go through all this work if you already know what the cube root of 64 is, but I'm just trying to show every single step here. Alright, now let's take a look. We have cube root of 3, 4, 5, 6. Yes. Alright, now you have cube root of 2 to the 6. So that's going to give us what? 2 to the 6 over 3, which will be 2 minus 4. And you're going to get 4 minus 4, which is going to go to 0. That's exactly what we wanted. So it checks. Now, make sure to write your answer in solution set. Do you see this right here? Okay, solution set is nothing but the little curly bracket. In a math class, we read this guy as solution set is 35. So, that's the answer. Okay, now let's go to the next one. Check your proposed solution, solve again. Alright, so again, notice that you're given the power of 1/2 power. Do you see that's equivalent to square root? So let me just rewrite it in that way off the bat. So here you're going to have square root of x minus 3 plus 8 equals 6. That's what you're given. All right, now when you solve this, you want to isolate a radical on the one side. Well, we only have one radical, so let's just keep that. And subtract 8 on both sides, and you're going to have minus 2. Okay, we're going to follow the same procedure as above. So in order for us to get rid of the square root, we're going to have to, what did I put this in red? Sorry. Let's go with orange. Square it. If you're going to square the left, you better square the right. Okay, now let's take a look. Then here on the left hand side, you're just going to have x minus 3 equals negative 2 squared is positive 4. Add 3 on both sides. Then here you're going to have x equals what? 7. So that's the proposed solution. But we need to check. Alright, so then I'm just going to write it in terms of the square root. So the square root of 7 minus 3 plus 8, does it equal to 6? This is what you need to ask. Alright, so let's compute that left hand side. 7 minus 3 is square root of 4, right? And then plus 8. Square root of 4 is 2, so you're going to have plus 8, which is going to be 10, which does not equal to 6. So in this case, your answer is going to be, so 7's not going to satisfy this equation, but the 7 is the only one that we got, so the answer is no solution. So the notation for the no solution is curly bracket with nothing in it. Okay, or you could just write no solution, whichever is okay. But now let's scroll back a little bit. Look at the second step here. Before I squared it, do you see that I have square root of x minus 3 equals negative 2? Can the output of the square root value, could it ever be negative? Heck no, right? So right there, you should know that this is such a false statement that there's not going to be any solution that is going to satisfy this equation. So you could have stopped right there and says, oh look, square root cannot output a negative value, so no solution. Or you could just go through the whole entire way like I just did. All right, anyways. All right, so let's take a look at this guy. Now, this one, please be careful. You'll see why I want you to be careful in a minute. I will point that out. Now, what we need to do first is isolate a radical on one side. So let's just keep the square root of x minus 4 on the left, and then let's subtract positive x square root of x plus 4 from both sides. Then here what we're going to get is what? Minus square root of x plus 4. I just moved this guy over like that. All right, now in order for us to get rid of that square root, again, what we need to do is what? Raise both sides by the to the second power. Now, this is the step that you need to be careful. Please note that 4 minus the square root right here is one chunk of a number. Okay, so what you need to do is, if you're going to square this, you're going to have to square the whole entire thing like that. Okay, now the common mistake is this. Common mistake is, I'll just write it in a different color. So, this is, don't do it. Don't do it this way. So if you have square root of x minus 4 equals 4 minus the square root of x plus 4. Here's a common mistake. You're going to raise, everyone knows that you're going to have to raise the left hand side by 2. And I know it's so tempting. You just want to raise each single one of them by 2. That is wrong. So that's the common mistake that I see on this problem every single semester. So don't do it. Okay, so this is not the correct way to do it. All right, but anyways, let's keep going. Now, square root of x minus 4 squared is going to give us x minus 4. Now, on the right-hand side, this means 4 minus square root of x plus 4. You're going to have to multiply that twice. Exponents indicates repeated multiplication. Alright, so now what we're going to have to do is we're going to have to FOIL the right-hand side of the equation. We're going to have to go like this, multiply that, multiply that, multiply that. Okay, so you're going to have x minus 4 equals 4 times 4, 16. And then you're going to have 4 times the minus square root. So you're going to have what? Minus 4 times the square root of x plus 4. Inner term is another minus 4 square root of x plus 4. The last term is negative. Negative is going to make a positive. Now here you're going to have square root of x plus 4, whole thing squared, which is just going to be what? X plus 4. Okay, but I'm just, again, I don't want to skip any steps, so I'm just going to write every step out. Alright, so now let's simplify a little. So you have 16, now you have minus 4 root, so it's going to be what? Minus 4 plus 4 is what? 8. Square root of x plus 4. And then plus, this is just going to become x plus 4. Okay, now what I'm going to do is I'm going to combine 16 and a 4 together on the right. So here you're going to have x minus 4 equals, what do we got? 20 minus 8 square root of x plus 4. Okay, now notice that after we went through all that, do you still see that annoying radical left over? So guess what? You're going to have to repeat the whole entire procedure again. Okay, so what we need to do is we need to isolate a radical on one side of the equation. So how about we keep the this radical on the right hand side, and let's move the 20 over. So I'm going to go minus 20, minus 20. Oh, you know what? I forgot this poor little plus x. Poor x. I'm so sorry. Sorry. Here we go. Plus x. Okay. So first I'm going to subtract, sorry about that you guys, subtract 20 from both sides. Then what do we got? We have x minus 24 equals negative 8 square root of x plus 4, and then plus x. Okay. Now let's see. Let's combine, because remember what you're trying to do. You want to isolate this radical right here. So what you need to do is get rid of this guy. Minus x and then minus x. Then what we got is negative 24 equals negative 8 times the square root of x plus 4. Okay, so we're almost home. Hard part is done. Okay, now let's look at this a little bit. Do you notice that 8 is going to go into 24 nicely, because 8 times 3 is 24? So, I mean, you don't have to do this if you don't want to, but it will make your life a lot simpler. If I'm going to divide both sides by negative 8, so that way, do you see why I'm doing that? Because look, if I square this right away, like this, I better square this whole thing, right? I'm going to have to square negative 24 squared and then negative 8 squared and then square the radical. Which is fine, which you know, it's not too bad, but I want to make my life simple as possible. So let's see what's going to happen if we divide this guy by minus 8 on both sides. Okay, so if I do that, then here you're going to have what? 3 equals 8, negative 8 is going to cancel, just the radical x plus 4. Oh look, so much nicer and it looks cuter. Okay. Now let's solve for x. So how do I get rid of the square root? Is raise this guy by the second power. That means we better raise the left hand side by the second power. Now you're gonna have 9 equals x plus 4 and minus 4 minus 4. Then here you're gonna have 5 equals to x is the proposed solution. Now what we want to do is check. Oh my goodness. Alright, so let's go over here. Let me change the color a little bit. Look at that. I have not used that color yet. So let's check. The proposed solution was what? X equals to 5. That was the proposed solution. So we're going to check. Okay, so the question is square root of 5 minus 4. I'm looking at the very top equation right here. Okay, plus square root of 5 plus 4. Does it equal to 4? That's the question. So let's work on the left hand side. Here you're going to have square root of 1 plus square root of 9. It's going to be what? 1 plus 3. It's going to give us 4 equals to 4. So it checks. So that means our proposed solution was the correct solution. So finally we put it in the solution set. So therefore the solution set is 5. Here it is. Okay. Oop. Okay, now let's look at the complex numbers now, right? Subtract. Write the result in the form a plus bi. Okay, so that means this. If you have something like, I'm going to make it up, 3 plus, I don't know, 7i over 3 or something like that. Now this is not in the form of a plus bi. How do I make it into a plus bi? Will be you split this guy up. Isn't this same thing as 3 over 3 plus 7i over 3? I mean, you look at it from right to left then. When you add the two fractions, you're going to have a common denominator, which we do, and then you just add the numerator, so we'll get this result. Okay, so that's how they want you to write it. Now if you can simplify this, so this is going to be what? 1 plus 7 over 3i. That should be the expression of your answer. Okay, so I'm just going to erase this for now. Erase. Just leave it like that. Okay, so let's do this. So all you have to do is this. Your job is to drop the parentheses. So when you drop the parentheses, remember, you're going to have to distribute the minus sign in. So don't forget to do that. That's another common mistake. So here you're going to have negative 13i plus 5 minus 9. Right here, be careful. Negative is going to become positive. Why in the heck did I write that positive so big? Okay, I'm trying to stress out that don't make that mistake, you know. And then here you're going to have what? 20i. Okay, next step is all you have to do is combine the like terms. So you have what? 5 minus 9, and then you have negative 13i plus the 20i. So here what you're gonna get is what? Let's go with the real part first. 5 minus 9 is what? Minus 4. And then you're gonna have plus 20i minus 13i. It's gonna give us what? Plus 7i. Now this is of the form a plus bi. So I'm just gonna box that for the answer. Okay. Now let's do this one. Find the product. Write the imaginary result in the form a plus bi again. Oh, yes. This one is another common mistake. So here is what not to do. Don't do it. Okay, I know it's so tempting, but 3 minus I square root of 5 like that squared. This does not equal to 3 squared minus I square root of 5 squared. No, that's an illegal math. That's a square root of 5. Oh my gosh. Okay, so please don't do that. This means multiply what's in the parentheses twice. That's what it means. So what you're going to have to do is this. Rewrite it as 3 minus I square root of 5. 3 minus I square root of 5. Okay, now guess what? You have to FOIL. So we're going to go like this. Multiply that inner term and the last term, just like that. Okay, so this is going to equal to what? 9 minus what is that? I times 3 square root of 5. The order doesn't matter. Everything's being multiplied. So you could have written this as 3i times root 5 or 3 root 5i. It does not matter. And then in the inner term, it's the same thing. Minus I times 3 square root of 5. And the last one, you're going to have a negative negative. So you're going to have a positive. And then you're going to have I square root of 5 squared. Again, I'm working this step by step by step. All right. Now let's take a look at, okay, so here we go. So this is going to equal to 9. Now, do you see that I can combine these two together? So, I'm sorry, maybe this looks really ugly and confusing, but let me just go one more step. Let me just try to rewrite this as 3 times root 5i minus 3 root 5i. Okay, and then let me just leave it like this. We'll work on this at the end. Okay, so do you see that I could combine these two now? Okay, so here you're going to get 9 minus 6 square root of 5i. All right, now let's work on the parentheses. Now, do you see that this portion here, I square root of 5 squared? Remember that 2 is going to distribute on I and also onto the square root of 5. So this means I squared square root of 5 squared. Now what's I squared? Negative 1 times the square root of 5 squared is just going to give you a 5. So this portion is going to be negative 5. Okay, so let me just write that out. So this portion is going to be plus I squared times the square root of 5 squared, which is negative 5. Okay, now we could combine the real parts, which is 9 and then minus 5 together, and what do we get? 9 minus 5 is 4, and then the imaginary part is going to be minus 6 square root of 5, and then you just put the I at the end, and that's your answer. Okay, all right, now let's look at we're almost home, you guys, hang in there. Okay, number 14, simplify to the form a plus bi. Now this looks a little bit different than the previous example. Now the trick is this: when you're going to have to simplify this, you're going to have to multiply the top and the bottom of the expression by the conjugate of the denominator. So what you need to do is you're going to have to, let me just put the parentheses here before I forget. So here you're going to have to multiply by 3 plus 7i. 3 plus 7i. Okay, now we have to FOIL. Okay. So we're going to go like this, and then this, and then that. Okay, so you're going to have 4 times 3, 12. 4 times positive 7i. And then 5i times 3. And then you're going to have plus 5i times 7i. Again, I'm doing this step by step. Now, bottom needs to be FOILed as well. So you're going to have what? 9 is the first term, plus 21i, and then minus 21i. And the last term is going to be minus 7i squared. Okay, now let's keep on simplifying this. So this is going to be 12, and then I know that I could combine the 28i and then also the 15i together. What is that? 43i. So let me just combine that together then. So I'm just gonna do it like this. Let's just combine these two. So you're gonna have plus 43i. Now let's take a look at this portion right here. Okay, so do you see that if I multiply this together, I'm going to have 5 times 7, and then I squared. But the thing is, what's I squared again? That's negative 1. So this is what? Equals 35 times negative 1, which is going to give us negative 35 here. Alright, but I'll just work it step by step onto this equation. So here you're going to have plus 35 I squared. It's going to be negative 1. And whole thing over, let's see, 9. And then, let's see, the bottom, you see that's going to cancel out. This always happens, by the way, when you multiply by the conjugate. The inner term and outer term is always going to cancel. Okay, and then be careful with the sign for this guy. It's going to have what? Minus 7i times, 7i squared is what? 7 squared times I squared, which is 49i squared. Okay, now let's deal with the I squared. I squared is negative 1. So I'm just going to rewrite this. So this is what? 12 plus 43i. And then, again, this is going to become negative 1. Okay, so here what you're going to get is what? I'm just going to cut negative 35. Okay, so be careful right there with the sign. And then, whole thing dividing by 9. And then what? Minus 49. Again, this portion is going to become negative. So, you know what? I'm just going to just write it in black. Sorry if I confused you with the color. I squared is again negative 1. Okay, so what do we get? You're going to have 12 minus 35 plus 43i, whole thing over 9. Now, this portion here is going to become what? Plus 49. And then, let's see. So what is that? 58 is on the bottom. And then let's do 12 minus 35, which is going to give us minus 23 plus 43i. Now, we want this in the form a plus bi, so last step, split it. So this is going to equal to negative 23 over 58, and then plus 43 over 58i. And that's the answer here. All right. Now the last problem. Simplify the expression I to the 400. Now there is an easiest way to do this, because look, let's start out with the I. Okay, so you're going to start with the I. Let's square the I. You're going to have what? Negative 1. Now I to the third is what? I squared times the I, but the I squared is negative 1. So here you're going to have negative I. I to the fourth is I squared times I squared, if you want to look at it in that way. So it's negative 1 times negative 1. So this is going to be positive 1. Okay. Now, let's just check. What the heck is going to be I to the fifth? I to the fifth is nothing but I to the fourth times the I. What's I to the fourth? That's 1 times the I, which is going to give us the I. Do you notice what's going on? Do you see that we're back to where we started? So what do you think it's going to be if I want to compute I to the sixth? This is going to be negative 1. What's going to be I to the 7? It's going to be negative I to the 8th, it's going to be 1. So do you see that no matter how many times you're going to raise the I, you have 4 choices, and also it repeats in cycles of 4. Okay, so all you have to do is this. Here's the cool trick. Okay, do you see the 400? Divide that guy by the cycle of 4, because I is going to go in cycle of 4. And what you want to do is look at the remainder. This is called the remainder theorem. It's not taught in this textbook. It's actually a graduate school material, but let's see. Okay, so do you see that the remainder is, in this case, is 0. So the remainder theorem is saying is this: I to the 400 is just I to the 0th power. Now anything to the 0th power, provided that I does not equal to 0, is 1. So that's your answer. Easy as that. Now if you didn't just get that, just take a look at this one. Okay, so let's just play around. Okay, so if I asked you, so this is it. Sorry, maybe I should box that in red. So this is the answer here. Okay, but now suppose I asked you, give me I to the maybe 17. What is that, right? So all you have to do is divide 17 by 4 and look at the remainder. Remainder is 1, right? So this is going to tell you this is going to be the I to the 17th is exactly equal to the I to the 1st, which is just going to be I. That's going to be the answer. Okay, so let's take next, I don't know, I'm going to make something up. I to the maybe 28. I just made that up. Do the same thing. All you got to do is 28 divided by 4. Hold on, my brain is so fried right now, you guys. Oh, so again, this one's gonna be remainder is gonna be 0, so that was not interesting. Okay, so I'm gonna erase. I'm gonna try to come up with a different exponent. So how about, I wish you guys were here and then you could just give me the random number, but unfortunately I'm just here sitting here by myself with my 2 dogs. So let's go with I to the maybe 30. I don't know what's gonna happen. 30 divided by 4. Alright, so let's see. Alright, looks like the remainder is 2. Oops, sorry. Okay, so the theorem says that I to the 30 is going to be equal to I to the 2nd power. What's I squared? -1. Boom, just like that. So you can feel free to use this method if you like. It just saves you a lot of time, and that's all. All right, so that will be it for going over the review sheet. Anyways, if you have any questions, please let me know, and also if I made a mistake, please let me know. And thank you very much for listening through this whole entire thing, and good luck on your exam.